Okay, so again, it's optional, these sessions that we're having from 1 to 2 o'clock. Yeah, if somebody just called in, if you could mute yourself, because we'll get background noise otherwise. Yeah, so again, these are optional sessions, okay? So the first thing I want to make sure everybody's okay with is sort of how you register. We're going to be using MyLab or MyMathLab as our platform for the course. To register for the class, you have to register through D2L. So the first thing you need to do is log into D2L and then click on the link for our class. And I'm going to show you, just in case you have problems with it, I'm going to pull this up and just kind of show you what you need to do. Just a second. Okay, so after you log into D2L and then click on the link for whichever class you're in, of course, this one's the 4W04 class, but you might be in the 4W02 class or the 4CO2 class. But regardless of which one you're in, at the very top here, you'll have all these buttons. You want to click on this content button. And then on the left-hand side, at the bottom, you should see this My Lab link, and you want to click on that. And what will happen is this will appear on the screen. And what you want to do is you want to click on the blue link here that says Pearson MyLab and Mastering Tools Launch. You want to click on that. Now, it's kind of strange because you do have this one at the bottom that says the same thing, but it's not in blue. And when you hover over it, it starts to turn gray. But one you want to click on is the blue link here at the top. And then after you click on this, it's kind of strange how they do this. I don't really like it. You actually do have to hover over the Pearson MyLab and Mastering words, and you'll start to see how it has a gray line across there. Then you actually do want to click on this particular link. It's hard to, it doesn't even look like it's a link until you hover over it. So be careful about this. You do want to click on that though. And then this page will appear, and it'll be a little different for you when you register for the first time. This little yellow box should say something like register for MyMathLab or something like that. Right now it says open MyMathLab, and that's because I've already registered for it. So once you click on this yellow link, then you can go through the registration process for MyMathLab. And of course, I can't show you that here because I've already done it. But when you register, it will ask you to create a username and a password, and then it's going to ask you how to pay for it. You can get temporary access for, I believe, a couple of weeks, or you could pay for it online immediately.
Sorry, Professor, to interrupt.
Yes,
when
go ahead.
Enroll in your course, it says it's not accepting registrations yet.
Are you going through the D2L?
Yes, I can try to relog out and go back in, but that's the mayor.
Which section are you in?
The section that you just told us about, the D2L.
Is it 4W04?
Let me make
or
sure.
4W02? Do you know which section? I can look it up if you don't know.
Yes, can you look it up, please? I'm sorry.
Okay. I will look it up. I don't want to do it right now, but I'm going to try to figure out what might be going wrong. So I'll look it up later. And what you can do is, if you could just email me, and I'll correspond with you that way. If you could just email me after the meeting.
Okay, no problem. Thank you.
And I'll try to figure out what's going on. So again, once you start registering here, the payment options, you could get temporary access. You could pay for it with a credit card. And I believe you can also use like a PayPal account. Okay. So yeah, try go through that. That's the first thing you need to do is make sure you register. And of course, if you have any problems with it, like Brittany mentioned, just go ahead and email me, and I'll try to handle it on a case-by-case basis so I can figure out exactly what's going on with each individual case. Okay. Okay, so then that's the first thing you need to do is register for MyMathLab. By the way, my math lab changed their name to My Lab, and so I'm more familiar with using the word My Math Lab. So, but it's the same thing. After you register, the next thing you need to do is sort of go through the orientation process in My Math Lab. So I'm going to show you that next, and then we'll start talking about chapter 1. Okay. Okay, so after you register for My Math Lab and you sort of, by the way, after you register for My Math Lab, you can access it through D2L by going to the same My Lab link at the bottom under the content button. But that's after you've registered for the first time, okay? Or you can directly log into My Math Lab by going to their website. You can do it either way. But regardless of how you get to My Math Lab, when you through the orientation, there's a couple of things you need to do. One is you can watch this orientation video that I've got here. And you could also read through the orientation document I have below it. That just kind of explains how everything works in My Math Lab, how the course works, like administratively when taking tests and whatnot. And then after you're done doing all that, then you want to go to the quizzes and tests button. And underneath there, there's an orientation quiz, which you can see here. It's not graded and get as many attempts on it as you want. The one thing, though, is you have to take it before July 18th. If you don't take it before that date, then I have to drop you from the class. So that's kind of like the official participation record for the class. I have to drop people that aren't participating in the class, and taking the orientation quiz is sort of your documented representation of being in the class. Okay. Make sure you do that before July, what is it, 18th. Okay. Okay. So again, if you have questions about anything in the orientation or whatnot, just email me and I can help you out. And in certain cases, we can also set up WebEx meetings if you're having like difficulties with other things. So having said that, what I really want to do today after this is sort of cover chapter 1 because it's on the calendar for today. So let's go ahead and talk about statistics, I guess. So chapter 1 is really just an introduction to statistics. And a lot of it is just terminology. There's a lot of words and definitions that we have to learn before we can proceed into chapter 2 and so on. And so what I'm going to do is sort of talk about these terms that we're going to be working with throughout the course. But I'm actually going to kind of do it through the homework, and I'm just going to show you kind of what the homework looks like and explain the terminology as I work through the homework. There's actually 3 sections in chapter 1. The first section is sort of an introduction to populations and samples, which are important ideas and statistics. So I'm going to pull that up first, and we'll talk about that. By the way, to pull up the homework in My Math Lab, it's under, for you, it's under this homework button. But for me, I have to pull it up under this course tools button. You won't have the course tools button on your side. You'll just have that homework button. Okay, so this is the first homework. I'm going to scroll through and start with I believe number 3 is a good starting point. Okay, so let me just sort of give you an overview of statistics, and then we'll talk about some of these homework problems in the first section. So kind of the basic idea, the fundamental idea in statistics is you're trying to study this large population, but the way we study it in statistics is we don't have complete information about the entire population. What we have information about is a smaller subgroup of the population called a sample. And we want the sample, the sample is much smaller than the population that we're trying to study. But what the thing we really want is we want the sample to represent the population. Even if it's smaller, we still want it to represent the population. And the way we generally try to get a representative sample is by picking people to be part of that sample randomly. That way you don't bias it towards one particular group. And that's kind of the fundamental idea in statistics. That is not going away anytime soon. That is basically what statistics is all about. We want to know something about a big population, but it's too costly or it takes too much time to actually ask every person in the population about what we want to know. So instead, we look at a smaller subgroup called a sample and we get information from the sample. And once we have information from the sample, we try to glean what that might mean about the population we're trying to study. And we want the sample to represent the population. And the best way of doing that is to randomly pick people from the population to be in your sample. If you don't do it randomly, then you might be picking people of a certain type consciously or unconsciously. Okay. So this very first problem deals with whether a study is sound or not, and it has to do with whether your sample is representative or not, or likely to be representative. And so what they did here is they surveyed 596 subjects from a larger population. So this is their sample. And they were asked how often they played sports. And the way they got their sample is they surveyed people using the internet, which is pretty common these days. There was a question on the internet, and they just asked people to respond to that question on a website. And 596 people happened to respond to it. And so the question is this a sound, like, is this a representative sample? The 596 people are sort of representing the larger population of everybody. And the answer is no. And the reason is because this is called a voluntary response sample. Even though this is a very common type way of getting a sample, it does not give us a representative sample. And the reason is because if you volunteer to be part of the sample, that the people that are more likely to be on the internet, first of all, are more likely to be part of this sample. People that who enjoy answering these sort of questions on the internet are more likely to be part of the sample. You're missing the people that either don't like the internet or don't like answering questions on the internet. You're missing their information, so they're not being represented here. And so that, anytime you have a voluntary response sample, the people that aren't volunteering their information, those people are not being represented. So even though this is a common way of sampling, it does not generate a representative sample. So this would be flawed. So in this next one, they surveyed 521 human resource professionals and asked them about the importance of your age during a job application. And the subjects were randomly selected by pollsters from a reputable market research firm. So in this case, you would say that this is probably not flawed because the people are being selected randomly, and the people doing it they are considered to be a reputable firm. They have no interest in the outcome of the survey. So this one would be something we would want to get a representative sample from. Okay, so this one, it says several studies showed that after drinking red wine, subjects had increased blood levels of antioxidants. Antioxidants have been associated with a decreased risk of heart disease, and a wine company financed the research, identify what is wrong. So this is a particular case where the people doing the research, the wine company, or they financed it at least, they have an interest in the outcome. And so you have to be concerned about whether this is a sound survey. You want to try to make sure that the people doing the research have no interest in the outcome. And so if the wine company is financing the research, then there's some concern that they may not be doing such a great survey. So that's something to be cautious about as well. Okay, and then the last couple of things here in this section, and then we'll move on to the next, is this is more mathematical, but we'll run into it later on. Sometimes you'll find that you'll get the percentage, like this one says, a polling company reported 49% of the people that they surveyed, 1,018, said that rising gas prices are very harmful. But they didn't tell us how many of the people that they surveyed, right? They surveyed 1,018 adults, but they didn't tell us the exact number that said that gas prices were harmful. They only told us that it was 49%. And so the problem that we're going to run into here is the only way to get the original number is on a calculator. You would multiply, well, first of all, 49% written as a decimal is 0.49. So you would take 0.49 and multiply it by 1,018. And the exact number you would get is 498.82. So part A is asking us, what would the exact value be? What is 49% of 1,018? And the answer is 498.82. That's what happens when you multiply 0.49 by 1,018. And notice that it's a decimal. That introduces a bit of a problem because we know that this number represents people, and you can't have like a decimal for a person. So it's either 499 or 498. And we don't know which one it is exactly. So what you could do is to test it is you take 499 and divide it by 1,018 and see what percentage you get. And you can take 498 and divide it by 1018 and see what percentage you get. But it could be that both of them round to 49% because this is a rounded number. Sometimes it's hard to tell which one is correct. In this case, they tell us the answer is 499. So it appears that 499 divided by 1,018 is rounds to 49%, but 498 divided by 1,018 rounds to probably 48%. And so for that reason, we know that 499 must have been the number of people that said gas prices are harmful or very harmful. So we'll run into this later on. Sometimes when you only have the percentage and the total number of people surveyed, don't know how many of them responded in this case saying that gas prices were very harmful. And the only way to get that number back is to multiply 1018 by 0.49. And sometimes even then you wouldn't know exactly which one it is. We could narrow it down to 499 or 498. And then after that, you'd have to actually see what percentage you would get for each number. So what's 499? What's the percentage for 499? And what's the percentage for 498? And if one of them rounded to a different number, then we know that the other number must be correct. So in this case, 499 rounds to 49%, and I believe 498 must round to 48%. And that means 499 is the correct number. Then part D, they just say, suppose 1,018 respondents, out of those 1,018 respondents, 99 said that gas prices are not harmful. What would percentage be? Of course, what you do there is you just take 99 and you divide it by 1,018, and you'll get 0.0972. Then, of course, you move that decimal 2 places to the right to make it a percentage, and it would be 9.72%. Okay. Okay. So I'll let you look at the rest of this homework, but I think that's pretty good overview of what's happening in chapter or section 1. So let's go ahead and look at the next section. Okay, so the next section we're going to look at when you collect data, a big part of statistics is you're collecting data from the larger population, right? That's what we call our sample. So it's important to know what type of data you're collecting. And so the next section is sort of a breakdown of the different types of data that you might run into when you collect data. Okay, so the first major breakdown when you collect data is you must decide whether it's qualitative data or quantitative data. And of course, the difference is quantitative data refers to numbers and qualitative data refers to like qualities. And so in this example, they collected area codes of telephone numbers from people that they surveyed. Even though area codes are numbers, those numbers don't represent anything numerically. So this is actually qualitative data. If someone gives you a list of area codes, those are just labels for different areas of the country. Those numbers don't mean anything numerical. So like 617 doesn't mean there's 617 people in that area. It's just a label. So this actually, it's kind of strange. It seems like this might be numerical data that you're collecting, but area codes are just labels. And if your numbers are just labels, then they're just qualities. So this would be an example of collecting qualitative data. Be careful about that. Now this one says, well, hang on. Yeah, I'll go back to this one. It says the number of wheels on different vehicles. So you go to one vehicle and you count how many wheels it has. Maybe it's a motorcycle and it's got 2, and then you have another vehicle that has 4, and maybe you have a truck that has like 6 or 18, whatever, an 18 wheeler. So the data that you're collecting are numbers, and these numbers actually mean something, right? They're not just labels. They're telling us that this motorcycle has 2 of these things, right? 2 represents something physical. And so this is a case of quantitative data, right? Not qualitative, it's not quantitative. And when you have quantitative data, we like to break that down into 2 major types. One is called the discrete type of data, and the other is called continuous type. So the difference there is discrete data, the numbers have to jump, is the way I would describe it. So if you think about wheels, there's no such thing as like half a wheel or 1/10 of a wheel. You have one wheel, or maybe you have 2 wheels, or maybe you have 3 wheels, but you can't have 1.5 wheels. And so if the numbers are jumping like 1, 2, 3, 4, something like that, that's called discrete data. So in this example, the data that we're collecting is quantitative and it's discrete, not continuous, because the numbers are jumping. Um, Here's another example. It says the time required by students to complete a statistics test. So let's say I have a class and I record for every student how long it took them to take the test, and I write that number down, and that's my data set. Well, obviously that's quantitative data. Those numbers mean something. And then they want us to tell us whether it's continuous or discrete. Well, in this case, it's continuous because it could take you 1 hour, 22 minutes, and 34 seconds to take the test. But if I were to record it accurately, it could have been 1 hour, 23 minutes, and 34.2 seconds for you to take the test. So time evolves in a continuous fashion. It doesn't jump by seconds. It doesn't jump at all. It's continuously evolving. And so when I'm collecting times for students to take tests, technically that I'm collecting continuous data. Now, maybe I'm writing the numbers down and I'm rounding them off to seconds, or maybe I'm rounding it off to the number of minutes. But time itself evolves in a continuous fashion. It doesn't jump by seconds or minutes or hours. It doesn't jump at all. It evolves continuously. So this would be an example of continuous data. Another example of this, sometimes it can be hard to tell the difference, but if you go to the gas tank and fill up your tank with gas, you might put in 13.2 gallons or 13.3 gallons. And so even though the gas tank shows it jumping by 0.1 gallons, technically it doesn't have to. The amount of liquid that you put into your gas tank doesn't jump by 0.1. It can jump by just a little bit. You can put in a little bit more gasoline. So that's a case where it's actually evolving continuously, right? You could add just a little bit more gasoline. It doesn't have to jump by a gallon or even a tenth of a gallon. It actually can jump by a little bitty amount. And so that would be continuous as well. Now, oftentimes what happens is we collect data on people. And so if you're counting people, then that would be discrete. Like how many people voted for the president, right? Then that would be, since that's people, that would be discrete, right? People jump by 1, 2, 3, 4, 5. You can't have half a person. Okay, as another example, this one says the volume of cola in a can is 11.2 ounces. They want to know whether the data that you're collecting is continuous or discrete. And once again, since it's a liquid, liquids can evolve continuously in the amount. They don't have to jump by a certain number. And so this would be continuous data. Okay, and then the next thing I want to talk about is when you collect your data and you report it, we're going to summarize it. It's called summary statistics. And so in this example, they say a sample of students is selected and it's found that 35% own a vehicle. So that's sort of like a summary of what happened in your sample. 35% of them said that they own a vehicle. We call this a statistic. So there's a difference between what's called a statistic and a parameter. A statistic refers to information from a sample. So this 35% is coming from the sample. It's the 35% of the sample. And so that's called a statistic. Whereas a parameter is information about a population. So I'm trying to find one that's a parameter. Okay, so this one. This one says a particular country has 55 states in it, and they add up the total area of the states, and they get 202,247 square kilometers. Oh, wait, okay, they add up the total area of the 55 states, and then they divide it up by 55. They divide by 55, so the average number for the area per state is 202,247 square kilometers. And they want to know what this number is. This number of statistics or is it a parameter? So the question is this number coming from the entire population, or is it coming from a sample? Well, it's coming from 55 states, and those 55 states are the entire country. So this is actually the entire population, right? It's the whole country. So this is an example of a parameter. It refers to information about the population. This is the average size of a state in this particular country, and it includes all the states, right? It's not a sample of the states, it's all of them. And that's why it makes it a parameter instead of a statistic. Okay, and then the last thing I want to talk about is, in this section at least, is what we call levels of measurement. Your data can have different levels of measurement. So the first level of measurement your data can have is called nominal. And in fact, these are the 4 levels of measurement. The first one is called nominal. And every step you move up, there's something added to, there's a condition that's added to the level of measurement. So nominal refers to this, to your data only having order. I'm sorry, only having categories. Sorry, only categories. So nominal data is simply data that has categories. So here's an example of that. If someone says, what types of movies are there? And we're going to, label them drama, comedy, adventure, documentary, like they do on Netflix or something. That's a nominal level of measurement, because all you're doing is you're creating categories for your data. So if that's all you have is categories, it's called nominal data, or nominal level of measurement for your data. The next level is ordinal. Ordinal has categories, but it has categories that can be ordered. So here's an example of ordinal. Maybe this is golf scores in a tournament. So you rank, whoever had the fewest shots in an 18-hole golf tournament, they would be ranked number 1. And then whoever had the next fewest shots would be ranked number 2. Well, the number of golf shots that you have for 18 holes puts you in a particular category, right? I shot a 69, so I'm in the category of 69s. And then the next would be 70s. That's another category. But then not only do you have categories, you can order those categories. You can say 69 is a better score than 70. And so when you rank them, you're actually creating, you're taking your categories and you're putting an order to them. And that's when it becomes ordinal data. So again, we're going to add a condition every single time. So nominal is simply categories. Ordinal is categories that have a meaningful order to them. The next one is interval. Okay, interval, you have categories that can be ordered or have meaningful order. And then additionally, you can find the difference between 2 different categories. The difference between them is meaningful. So an example of this one would be the water temperature measured in degrees Celsius. So you measure, this water over here and it might be 50 degrees, and you measure this water over here and it might be 40 degrees. So you've got different categories. You've got 50, 49, 48, 47, 46. Those are your different categories. They can be ordered. The order has meaning. So 50 and 40 50 is hotter than 40. So you have ordinal, you have the level of ordinal, but then you also have the level of interval, because 50 minus 40 is 10 degrees. And that number 10 is meaningful. The 10 degrees means it's a little bit warmer than, right? The 50 is a little bit warmer than the 40. 50 and 30 between how warm this water is versus how warm this other water is. So the differences have meaning in this case, and that's why this reaches the level of interval measurement. Now, one thing I want to mention is the next level of measurement is called the ratio level of measurement. And that's where ratios are meaningful. This does not reach the level of ratio. And sometimes it can be hard to tell the difference between interval and ratio. But let me try to explain what the difference here would be, why this does not reach the ratio level. When you have interval data, you might have 0 in your data, but the 0 doesn't mean anything physically. When you have ratio data, you'll have a 0, it's called a natural 0, and that 0 is the absence of something physical. And it's the bottom. You can't go below 0 in ratio. There's no negatives in ratio. In order to have a ratio, you must have a bottom, and the bottom is labeled as a 0. It's the absence of something physical. And once you have a bottom, then you can start comparing ratios, and ratios have meaning at that point. But if you don't have a 0, a bottom, that's called 0, then you can't have a meaningful ratio. And I'll give you the example here. This is interval data. 0 degrees, we have arbitrarily placed 0 degrees Celsius. That's where water freezes. That is arbitrary. You can go below 0, right? You can go to -10, -20, -30 degrees Celsius. So that is not the bottom. That's just an arbitrary assignment that we decided to put 0 at the freezing point of water. We can go below 0 and measure -10, -20, -30. So this does not have a bottom natural 0. Now let me pull up one that's ratio. Okay, so this is an example of a ratio one. It says you're collecting data like how many acres of land someone owns. Okay, so if you think of it, this one actually reaches the ratio level. First of all, you've got categories. I have 1 acre of land. Someone's got 2 acres of land, 3. So those are your categories. You can order them and they mean something. I have more land than someone else, so mine's 50 acres. Yours is only 20. So you can order them so it reaches ordinal level. Interval, do differences have meaning? 50 minus 20, yes, I have 30 more acres. That's something physical, 30 more acres, right, of land. So differences are meaningful. And now are ratios meaningful? I have 40 acres of land and you have 20 acres of land. I have twice as much land. Does that mean something physically? Yes. The the physical land, if you take yours and double it, then you'll reach the amount that I have. So that has meaning there. The ratio is meaningful. So the reason it's meaningful is because 0 is not arbitrary here. When someone says, I have no acres of land, that's the absence of something. That's the absence of land, right? Whereas in the water case, so this one's ratio, whereas in the Celsius, the one we did before, degrees Celsius, 0 degrees Celsius was not the absence of something. It was just an arbitrary place for us to put, the freezing point of water is at 0. But 0 didn't represent the absence of something physical. Here it does. You can't go below 0. I can't say that I have negative 10 acres of land. 0 is the bottom. It represents the absence of land. And so once you have sort of a natural 0 where it's the absence of something, then you can form ratios that have meaning. And that's the difference between this one and the previous one. So what I would do, I think the best way to tell the difference between ratio and interval is if it can go negative, then it can't reach the level of ratio. And if it can't go negative, then it's probably ratio, right? So negative 10 acres of land doesn't make sense here. And that's because you have a natural 0, the absence of land. Okay, so those are the 4 different levels of measurement that we can achieve when we have our data. So I'll let you look at some of those. And if you have questions about those, let me know. All right, and then the last thing I want to do, we have maybe 15 minutes here, is to talk about 1.3. So 1.3 is about collecting our data, the ways that we can do that. So there's 2 major ways of doing this. A lot of times people collect data just by observing what happens. And if that's the case, it's called an observational study. Another way of collecting data that's very common is to actually create an experiment. And in an experiment, oftentimes you take your subjects and divide them into 2 groups. And one's called the control group and the other's called the treatment group. The control group you leave untouched. You don't treat them with anything at all. They're just called, that's why they're called a control group. You just keep them the way they are. And then the other group is called the treatment group. And you actually treat them, and then you try to compare how that treatment affects the treatment group versus the control group. So it's important, if you have an experiment, you must have one group that's being treated with something and another group that's being left alone. In an observational study, that doesn't happen. In an observational study, you just see how many traffic accidents were there in July. You just observe it. You didn't treat anything, you just observed. Okay, and that's the difference. All right, so in this first example, they say 445 women. In a study of 445 women with a particular disease, the subjects were asked to complete a survey about diet upon arrival to a hospital. So what was their diet like? Now, if you think about this carefully, all they're doing is collecting data on these women about their diets. They didn't actually treat them with anything. It's not like they took them and divided up into 2 different groups and treated one group with something and left the other group alone. So this is not an experiment. All they're doing is collecting data. They're observing the information they get about these people. That's it. So it's an observational study. Okay, whereas this one is actually an experiment, because what they did here is they took 80 patients with stomach cancer, they divided them into 2 groups, and they gave one group a particular drug, an experimental drug, to see if it's effective in fighting cancer. And the other was given a placebo. Now, a placebo is just a sugar pill. It's a fake pill, and it's sort of in case there's a psychological thing going on where people who think they're being treated, maybe they respond in a more positive way and their body heals it themselves because of this positive energy they get from thinking that they're being healed. So oftentimes the control group is given a fake pill, which is called a placebo. But this is definitely an experiment, right? You've got 2 different groups. One's given a fake pill, which is the control group, and the other one is given the actual drug. And then you compare the 2 groups to see what effect the drug had on the people that had stomach cancer. So this is definitely an experiment, not an observational study. Okay, and then the last thing we're going to talk about is there are different ways of creating your samples or collecting your samples. The most common ones are called, I've already mentioned the random sample, which is the ideal one. But sometimes you'll see people collect samples using a system. That's called a systematic method. Sometimes you'll people use whatever's convenient for them, like internet surveys. It's very convenient for a website to simply put a question on their website and have people respond. That's a very convenient thing to do, but it's not giving you a representative sample. Then it's also called what's called stratified, which we'll talk about in a second, and then cluster sampling, which I'll talk about in a second as well. So this one says a researcher selects every 557th security number and surveys the corresponding person. So this is systematic. They've created a system. They've got a list of social security numbers and they just pick off every 557th person on the list. So that's systematic. This one, they say a poll is conducted by a certain research center. 1,280 adults are called after their phone numbers were randomly generated by a computer, and 12% were able to correctly identify the president. So obviously this is random. This is a random sample because a computer is just generating the telephone numbers at random. And so this is the ideal situation. Um, in this particular case, the sample that we get is likely to be representative of the larger population because when you select them randomly, there's no bias involved in it, conscious or unconscious. Okay, so this one is a cluster sample. So let's talk about what a cluster sample is. In a cluster sample, you take the uh, population and you break it up into subgroups called clusters. And then, this in this example, they say a man is selected by a marketing company to participate in a paid focus group. The company says that the man was selected because everyone in 5 randomly selected towns was being selected. So let's say you're studying the entire population of the U.S. and you break it up by town, by what town people live in, right? So those are your clusters. Every town is a cluster, a subgroup of the population. In a cluster sample, what you do after breaking it up into clusters is you simply randomly pick a few of those clusters. And so in this case, what they did is they picked 5 towns of all the towns in the US. So, again, all the towns in the US are clusters. And if you pick, let's say, a few of them at random, 5, then that's called cluster sampling. So what you're doing is you're taking all the people in those 5 towns, and that's going to be your sample. If that's what you do, then that's called cluster sampling, which is different than stratified sampling. In stratified sampling, you break the population up into subgroups like towns. But when you do stratified sampling, you pick people from each town or each subgroup. So I'd have to go to every single town and pick a few people from every single town. And what you're doing is you're strafing the larger population. That's why it's called stratified. So the difference is cluster sampling is you pick the entire, like if you pick 5 towns, you survey everybody in those 5 towns, every single person in those 5 towns. That's cluster sampling. Stratified sampling is I pick maybe one person from every town. That's strafing all of the towns. So here's another one. To determine customer opinion on their pricing, Greyhound Lines randomly selects 100 buses during a certain week and surveys all the passengers on those buses. All right, so in this case, the population consists of, all customers of Greyhound Lines, which could be, millions and millions of bus rides. And what they did is they only picked 100 of those. So the clusters here are the buses. And what they did is they picked only 100 of those buses, but they surveyed everybody on those 100 buses. And so that's cluster sampling. Now, if they had picked one person from every bus in their fleet of buses, right, just one person from each bus, then that would be stratified sampling. Okay, so here's an example of stratified. To determine her body temperature, Jean divides her day up into 3 parts: morning, afternoon, and evening, and then she measures her body temperature at 3 randomly selected times during each part of the day. So she's broken up her day into 3 clusters, 3 subgroups: morning, afternoon, and evening, and she's randomly picking 3 from each cluster: 3 in the morning, 3 in the afternoon, and 3 in the evening. So she's strafing her clusters. So this is stratified. Now, if she had just taken the afternoon and measured her body temperature, at every moment during the afternoon, that would be cluster sampling because she's taking just 1 or 2 clusters. And she's taking all the data from those clusters, right? That would be cluster sampling. Okay, and then last one would be like convenience. A television station asks its viewers to call in their opinion regarding the variety of sports programming that they have. So it's very convenient for them. They just have to set up a phone line, and then people call in. And so this is definitely convenient sampling. It is not a random sample, though. This goes back to the very first thing we talked about. This is actually voluntary response sampling. I get to decide whether to call in or not. And that is not a random sample. You might think it is, but it's not, because if I get to decide whether I'm part of your sample, then it's not random. People who like calling in and answering these surveys are more likely to be represented than the people who just hate calling in, or people who don't have phones. So this is definitely a convenient sample, but on top of that, this is not only a convenient sample, it is a voluntary response sample, which will not represent the population. So it's not random. Okay, so I think we've pretty much covered everything. I'll let you look at the rest of these. Anybody have any, we have like 5 minutes. Does anybody have any questions about anything? Okay, let me check the chat window first, just in case, and then we'll call it a day. So someone asked if their WebEx meeting is recorded. Yes, it's going to be recorded. I've recorded this, and then I'm going to post it somewhere in my math lab. I'll send out an email and let you know exactly how you'll be able to access it. But yes, you'll be able to view this again. Okay, well, if nobody has any questions, we're going to continue to do this from 1 to 2. So we'll do this again tomorrow, and we'll start talking about chapter 2 tomorrow, and then we'll continue this starting on Monday as well. So next week from 1 to 2, Monday through Friday. Okay, and so we're just going to continue to work through the course this way for statistics. Now, again, if you're taking the co-requisite class Math 0242, that will be a separate thing. This is simply the statistics portion. But that's only, some of you are taking the co-requisite class and most of you aren't. So for those that aren't taking the co-requisite class, this is the only thing you need to worry about. But if you're taking Math 0242, then there's something in addition to this that you're going to have to work on throughout the course. And we can talk about that later on. Okay. Okay, I guess we'll call it a day for now. And I guess I'll see you tomorrow at 1 o'clock. Okay. And by the way, if you have any questions about anything, just email me. And if we need to, we can also set up a separate WebEx meeting on top of this if you need help. Okay. Okay. I'll see you tomorrow. Bye-bye. Have a good day.